interrupts. We completed the interrupts of the related to the timers. Now there are total 6 interrupts. So that already we discussed. The timer related interrupts we have completed. Now let us see the remaining 3 timers which are related to the external hardware interrupts INTO and INT1. And last one is the interrupt related to the serial communication. Okay. Now let us see the hardware related interrupts. What is the interrupt service routine and the interrupt vector table of the hardware interrupts. Okay, I want to share the screen. Now coming to, is it visible, friends? Is it visible? I am sharing the screen.
Yes, sir.
Yes, friends. Hello, is it visible to all? Okay, I request all to mute. Now let us see. Go to the directly. So the remaining two interrupts, please note down INTO and INT1. So these are available on pin number of the port 3. In the port 3, you will get the two interrupts INT0 and INT1. So here you will get the interrupt vector table. Here you can see this is the INT0, that is the external hardware interrupt, and its RAM location is 0003. Okay, 0003, and at the pin number 12 and pin number 13, you can get the two interrupts related to the hardware called as external. Means we are connecting external circuitry to activate this interrupt. So they are named as a INTO. Okay, the name of the pin interrupt is a INTO. It is also called as the external hardware interrupt, and its ROM location is 0003. ROM location. This is called as the IVT, interrupt vector table. This table is called as the IVT, the second column. Okay, then the location on what pin? Pin number 12. You can see pin number 12 of the 8051 microcontroller. There we have the INTO, the ROM, location 0003 at pin number 12 of the port 3. Okay, P3.2 means port 3.2. And the one more hardware interrupt called as a INT1. Friends, please note down INT0, INT1. So you can see the ROM location for the INT1 is at 0013. This is called as the interrupt vector table. Okay, this is the interrupt vector table. And the pin where it is available, INT1, where we have to connect, is pin number 13, and the port is port 3. P3 means it is a port 3.3. Okay, so this we have to, now we are discussing. The INT0 and INT1. Already we have completed the timer 0, the importance of the timer flag, TF, okay, and how to activate the timer interrupts, and how to generate, how to write the code for the timer. Two examples, the generation was square wave. Okay, so that example is very important. How to generate the square wave and how to use the timers already were discussed in the last class. Now let us see the INT0 and INT1. Okay, then finally we have the serial communication, that is the last interrupt, the interrupt related to the serial communication. So there are again in the serial communication we have the two types of interrupts, RI and TI. So RI and TI are the two interrupts related to the serial communication interrupts. So RI means receive interrupt and TI means transmit interrupt. While discussing the serial communication, I have explained the importance of this RI and TI. Okay. Now let us see the hardware INTO, then INT1. Then let us move to the serial communication and let us conclude today's the interrupt chapter. Okay. Next class I want to start the model 4 and model 5. So these are the code already I explained how to create the square wave. Okay. Now the 8051 hardware. Okay. The topic is external hardware interrupts. The 8051 consists of two hardware interrupts. They are called as two external hardware interrupts at pin number 12 and at pin number 13. There are two hardware interrupts external. They are called as external hardware interrupts at pin number 12 and at pin number 13. So they are named as a INT0, INT1. Like timer 0 and timer 1, they are designated as INT0 and INT1. So interrupt vector table, just I have explained where where these interrupt service routine of the INT0 and INT1 is available. So the in that vector table you will find the 0003H and 0013H are set aside for the these two interrupts INT0 and INT1 in the interrupt vector table. So interrupt vector table is a fixed memory location table. These are the reserved. These are the reserved places. We should not have assign these memory locations to the other purpose. So how to activate the external hardware interrupts? There are two methods for activation of the external hardware interrupts. In timer, recall the timer 0 and timer 1. So timer 0 and timer 1, they are activated based upon anybody. How the timers related interrupts are activated? Ampadas, unmute. Pushpa,
Yes, sir.
Hello, Pushpa, I am asking a question. How the timer related interrupts activated? What is the condition? Hello. Okay. So timer related interrupts, timer 0 and timer 1, they will be activated based upon TF, timer flag. Friends, please remember, because the exams is offline, already explained, TF, timer flag. Based on the TF, the timer will be activated. Okay, so we record the TF, then we have to set 1 into IE, where into the IE interrupt enable register. Any interrupt will be activated. You can see the IE register. It will consist of all these 5 interrupts. It consists of all 5 interrupts. The 2 timers related interrupts, 2 external hardware related interrupts, and serial communication related interrupt. So each interrupt we can activate it. Let us assume the INT 0 we want to activate. Then we have to put 1 here into that IE register. Okay, in IE register, always the 7th bit. Okay, the last bit had to be, means nothing but the MSB. The MSB always had to be 1. Then only the interrupts are activated. The whole interrupts of the microcontroller will be recognized. If you don't put the 7 equal to 7 bit, okay, this is the 7th bit is equal to 1, then the interrupts are disabled. Okay, what is the first step? The IE is in IE, in IE register, the MSB bit you have to make 1. Okay, then you can see the remaining all the 5 interrupts. Which interrupt you want? If we want INT 0, in that INT 0 interrupt we have to make 1. Then the particular INT 0 will be activated. If you want INT 1 equal to the INT 1 related interrupt had to be activated, then we have to put it 1. Are getting? Then the serial communication is 0, the timer is 0, the remaining timer 0, timer 1, all are you have to put as a 0. Means the when you in which bit you will make the 1, that will be enabled. The interrupt related to that particular ISR will be enabled. So these are the basics you have to remember. Okay. Here also the same thing. Here also the same thing. The INT 0 and INT 1 had to be activated by making the IE equal to 1 at bit number 7. Then there are two. What are the two activation methods? Level triggered and edge triggered. There are two methods to activate the external hardware interrupts. Okay, so level triggered, first one, this is the level triggered and the edge triggered. So let us see what is the level triggered. Here you can see the activation of INT 0. How to activate the INT 0? There are two interrupts, INT 0, INT 1. Pin number 12, pin number, sorry, pin number 12 and pin number 13. Okay, pin number 12 and pin number 13 of the port 3. In the port 3, we have the these INT0 and INT1. So here you can observe INT0 you want to activate, then here you can see INT1. So INT0 is present at pin number 3.2. As I told, port number 3. Port number 3 means 3.2. P0, sorry, P3 dot 2 means second pin of the port 3. So it is a level triggered. You can see here level triggered means 0 and here 1. This is the edge triggered. Okay. Observe here there are two. There are two methods. One is the level triggered and second one is the edge triggered. This is the level triggered method. This is the edge triggered method. Both are shown in a single figure. Okay. This is the shown in a single figure. So INT0 we want to activate. So level triggered. It will be activated when you give a NOT gate. This is a NOT gate. Here if you have 0, it will give the 1 and it will be connected to the interrupt vector table. This is IVT. Then the in this 0003 in the wrong location you can observe there 0003. In this we have the interrupt vector. In this interrupt vector table we have the interrupt service routine. Interrupt service routine related to the interrupt service routine is a software subroutine related to the INT0. So in this same figure, you can observe there are two methods shown: level triggered and edge triggered. In level triggered, what we are doing, we are using a AND gate, sorry, NOT gate. This is a NOT gate which converts. Here we have the 0, so it will make here 1. Okay, so this is the condition. Okay, level triggered 0 to 1. The transition from 0 to 1. Then it will directly connect it to the this 0003. Then of the IVT, and in that IVT we have the inter-service routine related to the INT1, INT0. Okay, so this technique, the use of the 0 and use of a NOT gate. If we have 1, then it will be 0. So at that time it will not activated. Okay, it is a disable. Okay, you have to give 0 at the input side. Here you have to give the 0. Then only the INT0 will be activated. So this technique of use of the NOT gate, the input is 0 and connection to the 0003 of the interrupt vector table. Okay, is called as a level trigger. Okay, and second technique is called edge triggered. Edge trigger means the INTO will be activated when there is a transition. When there is a, you can see the transition from 1 to 0. 1 to 0 means high to low. This is a high. Okay, and this is the low. Whenever there is a transition from the high level to the low level, this is the 1 and this is the low. So at a time, the INTO will be activated. Okay, so this transition you can see here, high to low, high to low. So this low had to be monitored whenever there is a transition from to high to low. The INTO will connect to the IE0, that is a timer control register, TCON timer control register, and it will connect to the this IVT interrupt vector table of the 0003. So in that IVT, we have the ISR, interrupt service routine of the interrupt service routine related to the this INT 0. Okay, friends, is it clear? There are two methods for the level triggered, edge triggered. In level triggered, input is 0. We are connecting to the NOT gate. Here we are getting 1. Whenever it gets to 1, it will make the connection to the interrupt vector table. Okay. And in edge trigger, we have to observe, we have to monitor, the edge triggered, the low to the high to low transition. High to low transition we have to observe. And then whenever this transition is there, it will connect to the IE0, and through the IE0, it is connected to the this interrupt vector table. In that we have the IS. Okay, is it clear? There are two techniques, level triggered and the edge triggered. So based on some condition only, the interrupts are activated. Based on some condition only, the interrupts are activated. So here now you can see the second